Hello maths fans, upper and lower bounds. So this is kind of the opposite of rounding. It's interpreting rounded values, sometimes called error intervals or the limits of a rounded value. So let's have a look and think about what we're talking about here. So if we've got a man is measured 160 centimetres tall to the nearest 10 centimetres, what would be that man's minimum height? So he's rounded his height up. He said, I'm roughly 160 centimetres. What would be the minimum that he could have been? Well, if we think about a number line there, if I've got 159, that would round to 160. Obviously 160 would. 158, yeah, I'd round up to 160. 157, yes, I'd round up. 156, yes, I'd round up. 155 would round up to 160, to the nearest 10 centimetres. 154 would round to 150. So my minimum value that would round up to 160 to the nearest 10 centimetres is 155. That's my minimum height that this man could have been. If he was 155 centimetres exactly, he'd have rounded to the nearest 10 and got 160. If he was 154, no, we'd have rounded down. So we say the minimum value there, or the lower bound, is 155. That is the lowest boundary for his height. Thinking about the maximum height, what's the maximum his height could be? Well, he could be 161, 162, 163, 164. He couldn't be 165. This would round up to 170. However, 164 isn't the maximum either, because he could be 164.5, 164.9. He could be 164.99. He could be 164.9999999999999. So what we actually say is that the maximum is 165. It's definitely not 166. But we're going to use a little bit of clever maths to say that is the upper bound, but it cannot actually equal 165. Now, it could be 164.9, so we can't use 164 as the upper bound. That's not right. So what we do is we use inequalities to show this. It's between 155 and it can equal it. 155 is less than or equal to our value. 165, it's less than that and it cannot equal it. So you see this has the equals, less than or equals. This is just less than. Okay, that's how we state the limits of this rounded value. There's the upper and the lower bounds. And this sentence on the here, that would be our error interval. Let's look at a few examples, different examples. Actually, one thing to tell you is there's a kind of shortcut we can take to find the upper and lower bounds. And that shortcut is that whatever it's been rounded to, this has been rounded to the nearest 10 centimetres, the upper bound will be half of the rounding limit. So half of that is 5 centimetres. So we take that 5 centimetres, add it on to 160. So 160 plus 5 centimetres is going to give me 165. 160 minus 5 centimetres gives me 155. So whatever it's been rounded to, half that, then add it on and take it away from the rounded value. All right, let's look at that on this example. So we've got the width of a river is 28 metres to the nearest metre. So this has been rounded to the nearest 1 metre. So we're going to half that. Half of that is 0.5 metres. We won't say 50 centimetres. We want to keep the units the same. So we're dealing with metres here. We'll stick with metres. So half of what it's been rounded to is 0.5. And if we think about that, what numbers would round to 28? Well, 27.9, 27.8, 27.7, 27.6, 27.5. So that 28 metres is going to be between 27.5 metres take away the 0.5, and the maximum, add the 0.5. So it's between 27.5 and 28.5. Now it cannot equal this, but that's taken care of by the less than symbol. So it's up to 28.5, but not quite all the way there. Another couple of examples. Here is a mountain, 2,830 meters. This has been rounded to 3 SF, significant figures. So the statement about the height of the mountain, well, 3 significant figures there. Let's think about what this is. This is thousands, hundreds, tens, and units. So 3 significant figures in this case is the nearest 10 meters. And so half of that is going to be 5 meters. So half of the sort of degree of accuracy is 5 meters. Take that away, give me the lower bound. So 2830 minus 5 is 2825, and add it on here. So plus 5 here, 2835. And that is one way of calculating the upper and the lower bounds. Let's look at another one on decimals, this one. So we've got a sprinter, runs the 100 meters in 9.94 seconds. That's been rounded to 2 decimal places. So how long did that sprinter take? Well, if it's been rounded to 2 decimal places, we need to kind of consider the next decimal place, and we're going to add on sort of half of the second decimal place, so half of 100th. Kind of go to the next decimal place and make it 5 would be my advice there. So we're going to get 9.935 because we've taken away the 0.05, and on the other end 9.945 because we've added on the 0.005. So there we go. There's different upper and lower bounds calculations. Now we're going to get into applying those to some operations. So let's start off. We've got these 2 values have been rounded to 2 decimal places. So we're going to need the upper and the lower bounds. So we'll go for the lower for this one is going to be 2.625, and the upper is going to be 2.635. Then we've got the lower for B, so this is A. And then we've got for B, the lower is 7.725, and the B upper is 7.735. Now, in order to find the smallest answer for A plus B, fairly obvious, we're going to take the smallest value for A and the smallest value for B. So we're going to take A, the lowest value, B, the lowest value, and we're going to add those together. And I think what we get when we do 2.625 add 7.725 is 10.35. Where it gets a bit complicated is when we start dividing. Okay, let's think about what we're going to need when we divide. Am I going to need the biggest, the lowest, the upper bounds, lower bounds? Which ones am I going to need to get the smallest possible answer? Well, when I'm thinking about these division ones, I try and think of like somebody winning the lottery, and they're sharing, there's several people in their group who all chip in to buy tickets. Now, to get the most lottery win, he wants the biggest value that they're sharing, and he wants to share it between the least number of people. If you try and put money into this, it's usually a little bit easier. What we want is the smallest possible answer. So how are you going to win the least money? Well, that's going to be having the least money to start with. So lowest, or the lower bound for A, and then share it between loads of people. Dividing it by loads is going to be the way that you end up with the least money in your pocket. So if we want the smallest value, we're going to have to do the lowest for A divided by the biggest for B. And in this case, the lowest for A was 2.625, And the highest value for B was 7.735. Now, if trying to decide if you wanted the lowest or the biggest plays with your brain too much, what you can do is just try all of the combinations. There's only 4 combinations. Lower bound divided by lower bound, lower bound divided by upper, upper bound divided by lower, upper bound divided by upper. There's 4 calculations that it could be, so if you're ever really stuck, just try all 4 and then find the smallest answer. But much better to figure out which ones we need. And I think the answer for this one was 0.339 to 3 decimal places. Okay, biggest possible answer when we're subtracting. Again, try and get your head around this. Think about your bank balance. How am I going to get the biggest bank balance? Is it start with a big balance and take away, well, of course it's going to be start with a big balance, and then I want to take away very little. That's how I'm going to have the most money in my bank. So I want the upper bound for B, subtract the lower bound for A. So the upper bound for B, 7.735. Lower bound for A, 2.625. So when I'm subtracting, you've got to think through it and work out which values I'm going to use. And the answer for that one, I think, was 5.11. And then lastly, we have multiplication. Well, the biggest answer is going to be when you multiply the 2 biggest values. So we want the upper for A, upper for B. 2.635 times 7.735. And we would get an answer of 20.382 for that one. Anyway, that's some calculations with upper and lower bounds. Go and practice it. Get into that habit. The key thing is to kind of half the degree of accuracy. So if it's 2 decimal places, go to the next one along and put a 5 and then some placeholders. Take it away for the lower bound, add it on for the upper bound. Thanks for watching.